So today we're going to start discussing how to do table lookups. So I'm going to share my screen and we're going to start off by beginning from this presentation. And I'm going to give you kind of my rules for looking up tables. And the first rule is make sure you have the right table. Always go through your tables and make sure the table in the very description right at the top in the title matches your requirements, and make sure that it's got in contents, it's got results in a unit of measure that you're looking for. If you're looking for power, then and in watts, you make sure you can see the power in watts. If you're looking for horsepower or gallons per minute, make sure you've got the right unit of measure. Sometimes you just need to turn a few pages or look down further in an engineering manual, and you will find the right unit of measure. Second, check out the X and Y axis. Determine if the table is in the right range for your results that you're looking for. So what that means is I will scan down through the top to make sure that my table has a column that's appropriate for what I'm looking for. Like in the example I gave earlier, SO cord was not offered as a cable type, so I couldn't use that ampacity table because it didn't have SO cord. And then I go down to the left and make sure that it's a range. In the case of this table, it's got horsepowers between 1/6 of the horsepower up to 10 horsepower. So if I'm looking for the current in a 20 horsepower motor, this table isn't going to do the job. Third, select the right column. In the example I gave earlier, I was using a 115 volt motor. So I select the 115 column. Fourth is optional. If your data is in the table, select the table row and then, pull your finger along to the first column where your data is stored. If the answer is in the first column, you do the opposite thing. So sometimes you're going to find that the answer you want in the table. Sometimes you find the answer you want in the first column. So you match the table, then move it over. You match the column and move it over. Sometimes you have to round up. Rounding up is most common. For instance, I don't want to round down when choosing a wire size. If I've got an amp requirement, that might be, 25 amps, but by nearest wire size is one size larger, then I have to choose the larger wire. If I choose the smaller wire, I will potentially burn it out. So we're going to use a couple of samples here. This is an example if you're doing some framing. I love this example. I do a lot of framing, or at least have done over the years. And so one of the questions is, what is the maximum span for my deck joist if I'm using SPF, which stands for spruce, pine, fir? SPF is a typical generic designation for the lumber you might get at Lowe's. I'm using SPF 2x10 with joist 16-inch on center, which is a pretty typical on center. So first of all, at the top here, I see that I matched the title, deck joist spans, right? Good. Right down below it, I can see that I've got deck joist spans with no cantilever and then with cantilever. Well, I don't mention cantilever, so it's probably no cantilever. And then I've got 3 inches of my spacing center to center, and I've got 12, 16, and 24. Since I need a 16-inch on center, and actually it looks like I need to edit that because I think I said 16 foot on center. So let's flip that to 16 inches on center, and let's continue on with that slideshow. And so here I am, 16 inches center. I found the right column. And let's turn on my little laser pointer here. There's my 16-inch on center. I know it's SPF, which stands for spruce, pine, fir. So it's in this row. I know it's a 2x10. So it's in this sub row. So the answer is 13.7. That means the maximum span that I can run with a 2x10 is 13 foot 7 inches. That means I can have a potential width covered up with a 13 7-inch board. Now, if I have a 14-inch span in my design, is that going to be a problem? Yeah, it is. It won't meet specs. It'll probably bounce around too much and maybe even break. So you don't want to do that. If I have a 12-foot span in my design, is that going to be a problem? No, it's not. 13.7 is bigger than 12. As long as you put the right blocking in there, it's going to do the right job. So what I did here is, first of all, step 1, check your title to make sure you're going to have the right data. Right? That's step 1. Step 2, make sure the table's in the right range. So step 2, I made sure that it could handle a 16-inch span. It had 2x10s and it had SPF. Step 3 was select the column. So I selected the column, which is a 16-inch span column. And then step 4 was I selected the right row, and that gave me the answer at 13 foot 7 inches. All right, I'm gonna pause my recording. Okay, so now the next example is I'm selecting the right pump, right? So what model of pump could I buy if my well depth is 300 feet and I want to pump water at a rate of 100 gallons per minute? So the main objective is to pick the right pump model. So let's look at the title here. Submersible well pump performance at 40 PSI discharge pressure. Well, I didn't specify discharge pressure, but we can assume 40 PSI is your standard for a house. I've got a list of models on the left. So that sounds pretty good. And at the top, I can see a range of water feet, the well depth around the top there. And I'm giving capacities and gallons per minute as the actual content. So at the different well depths. So now that's great. Now this column over here, GPM, let's ignore that for now. That's the nominal GPM for the well design. That's not the actual GPM, gallons per minute, at the depth we're talking about. So the first step was done. It looks like I have the right title. Where did it go? Bring to front. Maybe I won't mess around with these. All right. Second step is I've got the right range of data. Third step is I'll select the right column. So my depth is 300 feet. So my column is right here. So I'm going to select 300 feet. And I want to pump water at a rate of at least 10 gallons per minute. Well, if I scan down through my list of pumps, I actually see 1, 2, 3 pumps that could handle 10 gallons per minute. So in this case, I have 3 viable options, and they are pump R214A, and let me turn on my, let's actually make a little circle thingy and show you that way. All right. So here I've got one that's just barely 10 gallon a minute. There I've got another one that's just barely 10 gallon a minute. But right down here, R310 15A, it's a 1.5 horsepower nominally rated at 10 gallon a minute, but it's a big sturdy pump and it can get technically 11.7 gallons per minute at 300 feet. So right there is the one I'd probably choose, but any one of those three pumps would be a viable option in problem 2. In sample problem 3, it's the same as when we talked about. You've got a THHN wire, which is your standard machine wire for use in plenums or in machine or in conduit, and a single conductor. So that would match that single conductor on the other page, running at 75 degrees with 100 amps. Well, I check my title. It's an ampacity table. I read the small print, and boom, is this the right table for a single conductor? No, it's not. I can't use this table. What about 3 conductors if it's 100 amps? Well, yes. So then I go down to 3 conductors. I find the right column for THHN. Actually, I think this is small enough that you're probably having a hard time seeing it. Let's make it a little bigger. Oops. All right. So THHN is in this column here. It's at 75 degrees C. So I'm underneath 75 degrees C. THHN is actually right there. And I need to have 100 amps. So down in my column, I see I've got 95 amps and 110 amps. Well, I better round up to 110 in order to handle 100 amps. So if I go over to the left, it says that I need 3 gauge, AWG, which is gauge. So I need 3 gauge wire to handle that 100 amps, which I need to round up to 110. Now the last example, and let me zoom this back down so I can see the whole thing. The last example is a pump curve where I need to 17 gallons per minute. My flow rate, I need a lot of water. I need 17 gallons per minute. What horsepower HP pump do you select if your well is 600 foot deep? Well, first of all, I know that I'm looking at 4-inch tri-seal pumps. I'm looking at different horsepowers on different curves. So in this case, each curve represents a different horsepower pump. And I know that because I've had a little horsepower number next to each one of these curves. On the left is my depth of the well in meters or feet. And on the bottom is my gallons per minute. So I've got gallons per minute, I've got depth, and it gives me different horsepower as a pump. So this does have the right data for me to do this analysis. And so I go over to the left, and it's 600 feet deep. So I go and find that lovely line that says 600 feet deep. And there's only 2 pump curves that cross that line. One of them crosses over here. And if I take that down to gallons per minute, it looks like it's about 12 gallons per minute. Is that 17? Nope. So I go to the other one and I take it down. It looks like it's slightly over 17. So the second pump, the one on the farthest right, which is a 5 horsepower pump, is the one I need to select.